Hi everybody. I recently made an impulse purchase and I bought 3 coolie loaches and I brought them home and I put them in an uncycled tank and I began trying to get these fish through the process of cycling a tank in. And I know how to do it. I've done it plenty of times in the past, and in this particular instance I had a lapse of judgment or memory or whatever you want to call it, and I wound up losing all 3 of the coolie loaches. So I am going to take this opportunity to talk a little more in depth about the nitrogen cycle, and we're going to dig a little deeper into it, what I did wrong, how you can get your fish through a cycle if you need to, and so on and so forth. And I'll get into what I did as the video progresses. First of all, let me start by saying, for everybody that is about to tell me about Chem Prime or about Safe Start or the starter biocultures you can put in your tank or whatever, hold your thoughts till the end. If you do still have comments about this stuff, by all means share them, but I will get into that too, so don't necessarily say something just yet because you may have your questions answered. So let's just talk about the nitrogen cycle first. Let's say we're going to get a tank cycled in. We're going to set up a tank. We're going to do it the old-fashioned slow way. We're in no hurry. We're going to take 6 weeks to do this. What's happening? What are we doing? Well, ammonia is a waste byproduct from decomposing organic matter. Whether it's fish food that's been eaten by the fish or it's fish food that's gone to waste on the bottom of the tank, decaying leaves, the woodwork in your tank, that wood is actually breaking down and decaying. All of this is producing ammonia. Well, ammonia is a toxin that, would kill your fish if it didn't get dealt with, but the way it gets dealt with is there's a species of bacteria that actually uses the ammonia as, we will call it, a food source for simplicity. It eats the ammonia. Its waste product is another chemical compound that is dangerous to your fish, but not as dangerous, and this compound is nitrite. The nitrite is a food source for a second species of bacteria that lives in your tank, and its waste product is nitrate. And then we do a water change and we remove the excess nitrates from the tank, and that's the nitrogen cycle. So when we set a tank up and it's a brand new tank, there's nothing in it, and we're going to let it take 6 weeks to cycle in. Well, once you set it up, you just let it sit there, you just let it start doing its thing. What I do is throw some fish food in the tank. I know you can buy ammonia. I don't know about using like household ammonia. I've honestly never really just done the way I'm describing this, the textbook way to cycle a tank in. I always put starter cultures in or whatever. Again, we'll get to that as we progress. This is probably going to be a lot of information in this video. So you get your tank set up, you throw some fish food in there, you let the fish food start breaking down. You don't have to do anything. The bacteria will get in there. It's like yeast or algae or anything else. It's just ubiquitous, and it will start growing in your tank. But try to think of the bacteria during this video. Try to think of it as little tiny animals rather than bacteria. These are all little animals. This is a little colony of animals that live in your tank, and they have needs like your fish or frogs or crayfish or anything. They have lighting needs, they have oxygen needs, they have temperature needs, they have pH needs, and they have food needs. The food is ammonia. So you've got to let the ammonia build up in the tank first. That's the first part of letting the cycle begin. So as the ammonia builds up, your bacterial cultures start building up, and they start breaking down the ammonia, and they start producing a little bit of nitrites. At first you're not going to see any nitrite at all. Once you start seeing the nitrite being produced, then you know your first species of bacteria is in the tank and it's starting to work on the ammonia, because you're now getting nitrite. It's the waste product from that first species of bacteria, so you know it's in there. You've got the nitrite. That's proof that it's beginning to happen. Well, the nitrite's going to start building up because it needs to build up sufficient quantities to feed the bacteria that is going to eat. The nitrite And then eventually you'll start seeing the nitrates being produced. And when the nitrates are being produced, now you know you'll begin to have these colonies of the second species of bacteria. And now it's a waiting game. Now it's just a matter of letting those colonies build up into sufficient numbers so that you've got enough to deal with the amount of ammonia that's going to be produced in your tank. Under prime optimal conditions, which is roughly 78, upper 70s in temperature, 70 degrees Fahrenheit that is, obviously, pH about 7.3 to 7.5 is where you want to be optimally. And you want to have well oxygenated water, and you need dark area, and you need surface area for the bacteria to grow. That's why our filter sponges and biorings and everything have lots and lots of surface area, and they're in the dark confines of our filters where no light's going to get on them and kill them. And they need food. They need ammonia in the water. Under optimal conditions, it takes 36 hours for one reproduction cycle to happen. If you're in a colder tank, if you've got say a 65 or 70 degree tank in your basement at room temperature and you got a betta fish or something in there that can deal with the colder water, it might take you 4 or 5 days to get one reproduction cycle. So it's going to take a lot longer than 6 weeks for a cooler tank to cycle in. If your pH is really high or really low, it will take longer for your tank to cycle in. Under optimal conditions, you get one reproduction cycle every 36 hours. So when you get a reproduction cycle, if you've ever played the game where you start with a penny and you double it for a month, at the end of the month you got a lot of money, well, this is the same sort of thing. If you start out with a small amount of this bacteria in your tank, it doesn't need a lot of food in order for it to double its numbers, but it doesn't take very long before those numbers are getting pretty big, and you now need a fairly sizable amount of food source if you want to double the number every time. If you've only got a little bit of ammonia being produced in the tank, you may not double the number, it'll just increase, but it won't double. So the longer you're going, I had a cat attacking one of the fish tanks behind me. The longer you're going into this process, the more it's going to slow down unless you're adding more ammonia to keep up with the rate of growth that your bacterial colonies are, developing into. So eventually you'll get the numbers where they're supposed to be. You'll get enough of both kinds of bacteria, and now you won't be showing any ammonia, you won't be showing any nitrate rather, and it'll all be ending up as nitrate in your tank, and you'll do your water changes and then your tank cycled in. And this process takes about 6 weeks. What I did was try to speed that cycle up. And I did it by taking the biosponge from a hang on the back filter in another tank, and I swished it around in my 10-gallon tank, and I put a lot of bacteria in the tank. I basically removed bacteria from one established filter, put it in another tank. That doesn't instantly make that tank cycled. It may, but it doesn't necessarily. And in this case it didn't. All that bacteria doesn't live in the water column. It's got to find a place to take root, so to speak. It's got to land somewhere and establish. That's got to be kind of in the, way down in the substrate or in the filter. It's got to be in a dark area of the tank. And, I had a small filter on the back, and it wasn't enough. Enough of it didn't take for me to actually get the tank cycled in. So I was still getting these little bits of ammonia that were building up over about a 24-hour period. So this is what I really want to start focusing on. Now that we've gone through the whole how the cycle works and how we establish a cycle, let's talk about a scenario either like mine, or maybe your filter broke and you had to put a brand new filter on it. So the tank's kind of established, but the filter's not there yet. Or something like that. You've got yourself in a situation where you've got fish in a tank that isn't fully cycled yet. What do you do? Again, let me reiterate, this is not how to cycle a tank in. This is exactly what I'm saying about if you're in a jam where you've made an impulse purchase, or your filter has had some issues, or something where you've got fish, they're in a tank, the tank is not cycled. let's assume that the tank's almost cycled and we're not starting from scratch and you're not trying to do it the long, slow way by putting fish in it. That's, let's not go to that extreme. Your tank is almost cycled, but it's not there yet. How do you get your fish through that without them dying? I love it when the gouramis try to groom the other fish. I don't know if the other fish like it necessarily, but I think it's neat looking. The key to getting your fish through that scenario is you've got to sit on that tank like a mother hen. You've got to check the water for ammonia, and you've got to do that a lot. I start out in this situation. I came home, I got the tank established, I swished the filter all around in there, I got the tank all gunked up, I let all that sort of settle while I was kind of acclimating the fish, put them in. I gave it 4 hours and I checked. I saw no ammonia being produced after 4 hours. That's a good sign. I came back 4 hours later and checked and saw some ammonia developing, so I knew it didn't take. I didn't get enough in there, or enough didn't establish. The tank's not cycled. So now I've got to go into high maintenance mode where I've just got to watch the tank like a hawk. So this is where it gets tricky. What you need in your tank as a food source to allow those cultures to grow is ammonia. But what you've got to get out of your tank so it doesn't kill your fish is ammonia. So what you've got to do is have enough ammonia in the tank that there's excess ammonia. There's got to be enough left over that it gives you growth of your bacterial colonies. They won't increase in numbers if there's not excess ammonia in the tank. But you got to keep that to an absolute minimum. My danger zone, I don't even like to see it get all the way to 0.25 parts per million. A quarter part per million is, red alarm bells are going off. If it's gotten that high, I really am doing a water change right now. So the trick is trying to keep it between some ammonia, but not 0.25. So you're walking a tightrope of allowing a little tiny bit of ammonia to build up in the tank, which allows those bacterial colonies to grow. And you got to do the same thing with the nitrite. You got to keep your eye on the nitrite. The nitrite's a little more forgiving. You don't have to be quite so panicky, but 1 part per million nitrate has killed. I lost a blue phantom pleco to 1 part per million nitrites. I'm sorry, nitrite. I've been saying nitrate. I meant to say nitrite. The nitrites are not as dangerous as the ammonia, but again, 1 part per million killed a sensitive fish like a blue phantom. So take the nitrite seriously too. I just go by the same standard. I keep it at 0.25 parts per million or lower. And that's what you do. You just sit on your tank like a mother hen. Now, what I was doing was I was going back to the only tank I have that has a hang on the back filter, and I was trying to steal more biomaterial. But remember what I just said. Under optimal conditions, it takes 36 hours to get a single reproduction cycle. So let's say when I switched it around, if I knocked 75% off, I'm down to 25% of the original cultures on there. If I waited a day and a half and under optimal conditions I got 1 reproduction cycle, it's only doubled to 50% of what I originally started with. So even if I wait a couple days and try to steal from that filter again, it's not really a lot built back up on that filter. So you can't just indefinitely keep stealing from the filter. If you've got multiple tanks, I do, but I don't have hang on the backs. I'd have to actually break down filters and stuff, and I just wasn't going to do all that. So what my mistake was I got sick of doing this 3 times a day, and I was doing sometimes 2 water changes a day. And after about a week, it just slipped my mind one night. I don't know whatever the reason was. I went to bed and just didn't think about it. When I got up the next morning, again, didn't think about it, and I just started my day. I turned all the lights on and fed everybody, and when I got on, hang on a second. I don't know why my cat keeps coming down here tonight and attacking the damn fish tanks, but he is. So long story short, it had been about 24 hours since I had checked the ammonia, and in that time, it raised up to about 1 part per million, and that was all it took. I did a water change immediately. All of the loaches were still alive when I did that water change, and it didn't matter. Within 24 hours, all 3 of them were dead because the ammonia had oxidized enough of the cells in their gills that their gills were no longer functioning properly. That's why when the fish have the ammonia poisoning, or they're suffering from ammonia, you'll see them up near the surface of the water a lot of times. They're gasping for air, so to speak. It's because their gills aren't functioning properly. It's not necessarily that there's not a lot of oxygen in the water. They're just behaving the way they would if there wasn't a lot of oxygen in the water, because their blood's not getting very much oxygen in it, because their gills are getting burned up by the ammonia. So that's why you get that behavior from the fish. So the way I just described doing that is the au naturel way of doing it. I don't really use additives or put anything in my tanks. I don't put ferts or foods in for my plants. I don't do CO2 injection. I don't do anything in my tanks like that. And I don't use Chem Prime, and I don't use water treatment stuff or anything like that. But I'm aware that that stuff's out there, so let's talk about that a little bit too. If I really wanted to keep this stuff on hand for just such a situations, and I'm not saying not to, this is how I do it. I'm not poo-pooing these products at all. They do a great job for what they do. But it's important to understand how they work. You can get yourself in some trouble using Prime in particular if you don't really understand what you're doing with it. So the only thing that makes all of what I just said kind of confusing is if you start talking about acidic water. With acidic water, the ammonia gets converted to ammonium. Instead of NHO3, it's NHO4, or the other way around. But it is the additional hydrogen ion gets forced onto the ammonia molecule, and that converts it into ammonium. And that's what pH is. The pH is additional hydrogen ions, and the more hydrogen ions you have in your water, the more acidic it is. So when you get down into where you're below a pH of 7 and you're into acidic water, you've got so many free hydrogen ions that they begin binding with the ammonia and they turn it into ammonium, which is harmless to your fish. So if you've got an acidic tank, you don't have a lot to worry about, really. I still don't like to see the ammonia in the tank, even though it might be ammonium. So I still do the water changes and I still go by the same principle. The beauty is the bacteria that eats the ammonia doesn't care if it's ammonia or ammonium. It still eats it just the same. Once it's in ammonium form, it's not hurting your fish anymore. So that's where, and I'm saying this because this is where Chem Prime comes into play. When you pour Prime in your tank to block your ammonia, and I would imagine most ammonia blockers function the same way, but I know for a fact this is how Chem Prime works. What it does is it forces a hydrogen ion onto the ammonia. I'm not sure the mechanisms of how that works, but that's what it does. It forces an ammonia to accept a hydrogen ion, and it turns it into ammonium and renders it harmless in your tank. So when you do your test, it's still going to show up as being ammonia in your tank. But you don't know if it's ammonia or ammonium. That's why I said I just don't like seeing it. If it shows up on my test kit, I'm doing a water change. And that's why I don't bother with the Prime. I don't care what it says. I don't care if I know the Prime is in the tank. Because here's the thing. Here's the real catch. Prime is forcing that ion onto the ammonia, and it can only hold it there for so long. When you're in acidic conditions, that ion is on there just because there's so many of them in the water. It's there, and it's going to stay there as long as that water stays acidic. Prime doesn't work that way. Prime is a temporary fix. It forces the ion onto the ammonia, converting it into ammonium. And the idea is while it's bound up as ammonium, your tank's nitrogen cycle will deal with it, and you just don't have to worry about it anymore. It's kind of like that emergency thing to get you through a day or two. Because even Prime, the company, Chem, says that it only lasts between 1 and 3 days before that bond breaks, the ion releases, and now you've converted back to ammonia. and it's now harmful to your fish again. So if you've got a bunch of ammonia in your tank and you're just pouring Prime in, and you know you're on a ticking time bomb. You know, at some point all of that's going to release and turn back into ammonia if your tank hasn't dealt with it. So the trick is still going to be getting your nitrogen cycle up and running. The Prime, again, it serves its purpose as long as you understand what you're doing with it and you know how it works and you know what you're getting yourself into. Go ahead and use it. It serves its purpose. It works. I prefer to just do it the old-fashioned way. If I see ammonia building up, I do a water change, you know, and then I wait 6 hours and I test the water again. I'm not down with just pouring something in my tank and saying, well, that takes care of the ammonia, and I'm not down with that. I'm going to do a water test. If I see ammonia, it's getting a water change. You know, if I've put the Prime in there, I'm still doing a water change. I don't care. If it says there's ammonia in my tank, I'm doing a water change. None of my tanks are acidic, so when I see ammonia, I just do my water changes, and that's the way to do it naturally. If you're in a jam where you don't have Prime, like maybe you can order it, but it'll take a couple days, or you got to run down to the store tomorrow to get it, that's fine too. Just the way to get yourself till tomorrow is by doing a water change and checking your water. So you have to have a test kit. If you don't have a test kit, don't even think about attempting this. And in fact, not having a test kit to me is like having a kid and not having like a thermometer to be able to take his temperature if they're sick or something. Like, you have to have a test kit if you've got an aquarium, even if it's a dip test, like the little strips or something. That's better than nothing. But without a test, you have no way of knowing what's going on in your tank. So if you're going to attempt to do this, don't even think about it without doing a test, because you're going to have to do 2 to 3 tests a day for as long as it takes. And you may have to do 1 or 2 water changes every day for as long as it takes until your tank finally cycles in. Because remember, when you're only allowing a little tiny bit of ammonia to build up, you're only allowing a little tiny bit of growth to your bacterial colonies. It's going to slow the process down by doing this. So optimally, we don't want to do this. We don't want to make these impulse purchases. You know, that's not the point of this video. This isn't a like, hey, this is a good way to cycle your tank in kind of video. And on that final note, I will say that for anybody that thought this was going to be a video about fish in cycling, my thoughts on fish in cycling are that it is just ridiculous to even do that. It's just so not necessary. And if you're not familiar with what fish in cycling is, it's simply using fish as sacrificial fish. Most people use guppies, or sometimes people will recommend throwing some mollies or something like that in because they're cheap and inexpensive. And the fish is simply in the tank to provide a source of ammonia so that the bacteria will have food to eat. And as the ammonia builds up, it kills the fish. That's what fish in cycling is. You're literally killing a fish for the sake of putting ammonia in the tank, which is so pointless. You can, if you really want, you can go and buy ammonia, or I don't know, I wouldn't necessarily use household ammonia, I don't know, I've never done it this way, but you can buy ammonia and you can pour ammonia in the tank. Personally, what I do is I throw fish food in the tank, and the fish food breaks down and becomes ammonia, and you've got a source of ammonia in your tank. The food doesn't have to go through a fish in order to turn into ammonia. You know, so this video was about how to get yourself through a sticky situation if you made some unwise choices and ended up with a fish in a tank that's not necessarily cycled, or if something went wrong with your filter or something else. So I hope that helped clear up a few misunderstanding about Prime, and I hope it helped you get a little better understanding of how the nitrogen cycle works and fish in cycling and everything else. So please subscribe if you're not already, that way you won't miss anything I got coming up. You never know what you're going to get with me. So thanks for watching this one. I'll see you real soon in the next one.